Assalamualaikum and hi everyone. So today we are going to continue with Chapter 7 on Database and Information Management. The learning objectives in this topic are: the first one, what are the problems of managing data resources in a traditional file environment? What are the major capabilities of Database Management System (DBMS) and why is a relational DBMS so powerful? What are the principal tools and technologies for accessing information from databases to improve business performance and decision making? This chapter will discuss the role of databases for managing a firm's data and providing the foundation for business intelligence. By now, you should have encountered any databases on the web. For example, Google and Amazon are database-driven websites. Travel reservation websites, Facebook, and iTunes are also database-driven. So, why are these websites, such as Facebook, iTunes, Google, and Amazon, are driven by databases? What is it about databases that makes the creation and use of these sites more efficient? Before we go into more detail about database, what is the difference of database, data, and information? Are those the same thing? Database is a collection of data organized in a manner that allows access, retrieval, and use of that data. So database can be saved as a table and contains the field name and also attribute. Data is a collection of unprocessed items such as text, numbers, image, audio, and also video. Information is the processed data. It can be the text, numbers, images, audio, and also video. Information is the meaning of the data. For example, we have this number 1234. So this is a data because it has not been processed. When we know that 1234 refers to the matrix number, then that data is now changed to an information. Say that we have other matrix number as well. The collection of those matrix number, which are the data, can be organized inside the database that allows any access, any retrieval, and use of that data. File organization terms and concepts. This slide describes a hierarchy of data that is used to store information in a database, progressing from the database as the top-level holder of information down through the field which stores information about an entity's attribute. This hierarchy is illustrated by the graphic on the next slide. Database is a group of related files. Files refers to the group of records of the same type. A record is a group of related fields. A field is a group of characters as words or numbers. An entity is a person, place, or thing on which we store information. An attribute is each of the characteristic or quality describing the entity. In this figure, looking from bottom to top, a computer system organizes data in a hierarchy that starts with the bit, which represents either a 0 or a 1. Bits can be grouped to form a byte to represent one character, number, or symbol. Bytes can be grouped to form a field, and related fields can be grouped to form a record. Related records can be collected to form a file, and related files can be organized into a database. This graphic illustrates the hierarchy of data found in a database. It shows the student course file grouped with files on students' personal histories and financial backgrounds that form the student database. It illustrates what data is found at each hierarchical level from the database level down. making up the smallest information unit, the field or smaller unit of data common to all applications, bits and bytes. A bit stores a single binary digit, 0 or 1, and a byte, which is 8 bits, it stores a group of digits to represent a single character, number, or other symbol. A data hierarchy for a student database includes the following sections: database, including course file, financial file, and personal file. File, an example of which is a course file including student IDs, courses dates, and grades. Record, field such as IS-101, which is a course field. Byte, such as 01001001, which is the letter I in the ASCII code. Bit, for example, is 0. Problems with the traditional file environment. This slide discusses the problems in data management that occur in a traditional file environment. In a traditional file environment, different functions in the business, such as accounting, finance, and HR, they maintain their own separate files and databases. As a result of that, they would have data redundancy, data inconsistency, program data dependence, lack of flexibility, poor security, and lack of data sharing and availability. For example, if one department has updates the information inside their files, it is not automatically being updated in the different department. So, different departments might have different information that is being saved. That causes the data inconsistency problem. In terms of data redundancy, each department might have saved the same information. This is a waste of storage, as that information can be centralized. Traditional file processing. The use of a traditional approach to file processing encourages each functional area in a corporation to develop specialized applications. Each application requires a unique data file that is likely to be a subset of the master file. These subsets of the master file lead to data redundancy and inconsistency, processing inflexibility, and wasted storage resources. This graphic illustrates a traditional environment in which different business functions maintain separate data and applications to store and access that data. Looking from this graphic, what kinds of data might be shared between accounting or finance and HR? What about between sales and marketing and also manufacturing? In the diagram, a cylinder shape represents the master file with data elements A to Z. Accounting and finance users via application program 1 require derivative files A, B, C, and D. Human resources users via application program 2 require derivative files A, B, D, and E. Sales and marketing users via application program 3 require derivative files A, B, E, and G. Manufacturing user via application program 4 require derivative files A, E, F, and G. We can see that for all users, they have data element A in common. So, data A can be shared by all, so there is no need to create a derivative which is redundant. Currently, if one part in file A is changed, there would be inconsistency in all the information held by all the users, because once file A is changed, then all the users need to change their file A. This is because all the users, they only have the derivative files, which is a copy of the master file. The derivative files does not affect the master file if any changes is done to it. Database management systems. This slide defines and describes databases and DBMS. Database is a collection of interrelated rows, columns, and tables. It serves many applications by centralizing data and controlling redundant data. Database Management System (DBMS) is a system software for creating and managing databases. It manages the data by storing and retrieving from the database. DBMS interfaces between applications and physical data files. It separates logical and physical views of data. What is a logical view? So, logical view, for example, are forms. It is derived from the tables for the end user. It represents data in a meaningful format. Physical view, for example, tables. It is the way that data are organized and structured on the physical storage media. DBMS solves problems of traditional file environment. It controls the redundancy, eliminates inconsistency, couples programs and data, and it enables organization to centrally manage data and data security. So everything will be at one place. Human Resources Database with multiple views. A single human resources database provides many different views of data depending on the information requirements of the user. Illustrated here are two possible views, one of interest to a benefits specialist and one of interest to a member of the company's payroll department. This graphic illustrates what is meant by providing different logical views of data. The orange rectangles represent two different views in an HR database, one for reviewing employee benefits and the other for accessing payroll records. You can think of the cylinder as the physical view, which shows how the data are actually organized and stored on the physical media. The physical data do not change, but a DBMS can create many different logical views to suit different needs of users. At the center of the diagram is the Database Management System (DBMS). It has a reciprocal relationship with the Human Resources Database, which contains the following data. It has the employee ID, name, SSN, position, date hired, gross pay, net pay, life insurance, pension benefit, and also health care. In the payroll view, the Database Management System (DBMS) provides only the following data, such as the name, SSN, gross pay, and net pay, while in the benefits view, it provides only the name, SSN, and the health care. Based on this, we can see that DBMS can create many logical views and give them access to the database accordingly. All the data in the database cannot be accessed by everyone unless they are given the permission to do so. There are many database models such as hierarchical, network, relational, and object-oriented. Database model determines how the database organizes the data. This slide introduces the most common type of DBMS in use with PCs, servers, and mainframes today, which is the relational database. In relational DBMS, it represents data as a two-dimensional tables. This means that it has rows and columns. Each table would contain the data on entity and attributes. Table, which is the grid of columns and rows. Rows is the records for different entities. Fields, which is the columns, it represents attribute for entity. Key field are fields used to uniquely identify each record. So we have primary key and also foreign key. Primary key is the key in the table used for key fields. Foreign key is the primary key used in a second table as lookup field to identify records from the original table. A relational database organizes data in the form of two-dimensional tables. Illustrated here are tables for the entities supplier and part, showing how they represent each entity and its attributes. Supplier number is a primary key for the supplier table, and it is the foreign key for the part table. Supplier number in the part table is the primary key in the supplier table, so it is being used as lookup field to identify the records from the original table, which is the supplier table. Make sure that you understand the concept of key field, which is the primary key and also the foreign key, and how those keys are being used to connect between different tables. The diagram shows examples of relational database tables. The supplier table contains 6 columns, which are attributes or fields. They include supplier number, supplier name, street, city, state, and zip code. The rows in the table are filled with brackets. The supplier name column is indicated as the key field. This primary key is the main identifier for that row of data. The part table contains 4 columns. The first column, part number, is identified as the primary key. The fourth column, which is the supplier number, it is identified as the foreign key. For example, if we have another table, then if that table is connected to part, then the foreign key in that new table would be the part number. Remember that foreign key is the primary key used in the second table as a lookup field to identify the record from the original table. The primary key in one table will become the foreign key in another table. Operations of a relational DBMS. This slide describes how information is retrieved from a relational database. These operations, select, join, and project, are like programming statements and are used by DBMS developers. Typically, they are using the query language, SQL, or also known as SQL. 3 basic operations used to develop useful sets of data. Select create subset of data of all records that meet stated criteria. Join combines relational tables to provide user with more information than available in individual tables. Project creates subset of columns in table, creating tables with only the information specified. For example, based on our supplier and part tables from previous slide, we can select from the part table, join with some information from the supplier table, and use project to create a new table with only the information specified. The 3 basic operations of a relational DBMS, the select, join, and project operations enable data from 2 different tables to be combined and only selected attributes to be displayed. This graphic illustrates the result from combining the select, join, and project operations to create a subset of data. The select operation retrieves just those parts in the part table, whose part number is 137 or 150. The join operation uses the foreign key of the supplier number provided by the part table to locate supplier data from the supplier table for just those records selected in the select operation. Finally, the project operation limits the columns to be shown to be simply the part number, part name, supplier number, and supplier name. So this is being shown in the orange table. From the first database management table, parts, two part numbers are selected. The supplier numbers from those two parts in the parts table are joined to the supplier numbers in the supplier table. These selected data are displayed or projected in a third table. This slide discusses the three main capabilities of a DBMS: its data definition capability, the data dictionary, and a data manipulation language. In data definition capability, it specifies the structure and content of the database. Data dictionary stores the information about the data in the database, including the names, definitions, formats, and descriptions of the data element. In querying and reporting, we use the data manipulation language, for example, Structured Query Language, SQL, or SQL. It is a specialized language for accessing and manipulating the data in the database. Note that the data manipulation language is the tool that requests operations such as select and join to be performed on the data. Many DBMS have report generation capabilities for creating reports, for example in Microsoft Access. Microsoft Access has a rudimentary data dictionary capability that displays information about the size, format, and other characteristics of each field in a database. Displayed here is the information maintained in the supplier table. The small key icon to the left of supplier number indicates that it is a key field. This graphic shows the data dictionary capability of Microsoft Access. For the field supplier name selected in the top pane, definitions can be configured in the General tab in the bottom pane. These general characteristics are field size, format, input mask, caption, default value, validation rule, validation text, required, allow zero length, index, Unicode compression, IME mode, IME sentence mode, and smart text. SQL Query. Structured Query Language, SQL or SQL, is a query language that allows users to manage, update, and retrieve data. For example, here it shows the SQL that is being used. So to write the SQL query, you would write select and then the fields that you want to use from the table name, where the condition is, and also how you want to order it by, which is sorting the result. If you want to know more and learn about how to write the SQL, you can go to the website w3schools.com/sql. Example of an SQL query. This graphic shows an example SQL statement that would be used to retrieve data from a database. In this case, the SQL statement is retrieving records from the part table whose part number is either 137 or 150. If we look at the statements carefully, the first line, we are selecting which table and which fields, where it says select from table part, field, part number, and also part name. And then we are selecting from the supplier table, the supplier number, and supplier name. And these are from table part and also table supplier. The next line where we write our where, that is the condition that we have. In this condition, we are saying that the foreign key should be equal to the primary key in two tables, which is from table part and also table supplier. Another condition that we have is it should be part number 137 or the part number is 150. This figure shows how you can construct it using Microsoft Access query building tools. It shows the tables, fields, and selection criteria used for the query. This Microsoft Access query, it performs the same operation as the SQL query in the last slide. The query pane at the bottom shows the fields that are requested, the relevant tables, the fields that will be displayed in the result, and the criteria limiting the result to part number 137 and 150. This is doing exactly the same thing as what we saw earlier. So we have our select, and we select the fields from the table name, where, the condition, and also how to order it by. By using Microsoft Access, you don't actually have to know how to write the SQL statements. You can build a form by using Microsoft Access. You can do so by clicking the Create tab and selecting the Form option. You can add any fields that you want, for example, matrix ID and also name. By doing it this way, whatever that the user input will be saved directly into your database. Here is showing an example of a form that you might have seen on other websites. A form is a window on the screen that provides areas for entering or modifying data in a database. For example, if you create a new Facebook account, it will ask for your details. Those details that you enter in the form are being saved in a database. In Microsoft Access, it can generate a report based on your database. A report generator allows user to design a report on the screen, retrieve the data into a report design, and then display or print the report. So you can see all the information that has been entered by the users. On this slide, it shows an example of a report where you can see all the fields from the form that the user has entered their details on. This slide describes activities involved in designing a database. To create an efficient database, you must know what the relationships are among the various data elements, the types of data that will be stored, and how the organization will need to manage the data. Conceptual design versus physical design. The conceptual database design is concerned with how the data elements will be grouped, what data in what table will make the most efficient organizations. In physical design, it transforms entities into tables, instances into rows, and also attributes into columns. Normalization, streamlining complex groupings of data to minimize redundant data elements and awkward many-to-many relationships. Referential integrity. It is rules used by Relational Database Management System to ensure relationships between tables remain consistent. It is achieved by having foreign key in the associated table reference a primary key value in the primary or the parent table. Entity Relationship Diagram. One technique database designers use in modeling the structure of the data is to use an entity relationship diagram. It uses symbols to illustrate the types of relationship between the entities. There are several different types that are available, such as one-to-one, one-to-many, and also many-to-many. And a normalized relation for order. This figure shows a relation before normalization. We can see that it contains repeating groups. For example, there can be many parts and suppliers for each order. There is only a one-to-one correspondence between order number and order date. Here, one table lists the relevant data elements for the entity order. These include all of the details about the order, the part, and also the supplier. An order can include more than one part, and it may be that several parts are supplied by the same supplier. However, using this table, the supplier's name and other information might need to be stored several times on the order list. That's why we call it as unnormalized relation, because it contains repeating groups. After normalization, the original relation order has been broken down into 4 smaller relations. The relation order is left with only 2 attributes, and the relation line item has a combined or concatenated key consisting of order number and part number. This graphic shows the normalized tables. The order table has been broken down into 4 smaller related tables. Notice that the order table contains only 2 unique attributes, order number and order date. The multiple items ordered are stored using the line item table. The normalization means that very little data has to be duplicated when creating orders. Most of the information can be retrieved by using keys to the part and supplier tables. It is important to note that relational database systems try to enforce referential integrity rules to ensure that relationships between coupled tables remain consistent. When one table has a foreign key that points to another table, you may not add a record to the table with the foreign key unless there is a corresponding record in the linked table. For example, foreign key supplier number links the part table to the supplier table. Referential integrity means that a new part cannot be added to the part table without a valid supplier number existing in the supplier table. It also means that if a supplier is deleted, any corresponding parts must be deleted as well. This figure shows an example of an entity relationship diagram. It shows that one order can contain many line items. A part can be ordered many times and appear many times as a line item in a single order. Each line item can contain only one part. Each part can have only one supplier, but many parts can be provided by the same supplier. The entity relationship is represented by the symbol or the arrows. It shows one-to-one or one-to-many relationship. Databases and the web. Many companies use the web to make some internal databases available to customers or partners. The typical configuration includes a web server, application server or middleware or CGI scripts, and database server which hosts the DBMS. There are several advantages of using the web for database access. Ease of use of browser software. The web interface requires few or no changes to the database, and it is inexpensive to add web interface to the system. Linking internal databases to the web. Users can access the organization's internal database through the web using their desktop PC browsers or mobile apps. In this diagram, there are 6 elements of connecting to the web's database. Here we have the client with the web browser, connecting using the internet to the web server, application server, database server, and to the database. Each of these elements is linked to its neighbor by a bidirectional arrow. It means that it can retrieve and send the data. A web server handles the web request. It deals with the presentation and serving the web content to the client. The application server manages and processes the data, while the database server handles any database queries and runs on MySQL, for example. Establishing an information policy. This slide is looking at the firm's need for an information policy in order to ensure that firm data is accurate, reliable, and readily available. It includes the rules, procedures, roles for sharing, managing, and standardizing the data. In establishing the information policy, different groups of people are in charge of different parts related to the database. Data Administration Group, they establish the policies and procedures to manage the data. Data Governance Group, they deal with the policies and processes for managing availability, usability, integrity, and security of the data, especially regarding the government regulations. The Database Administration, they create and maintain the database. Although the Database Administration Group establish and create the physical database, the Data Administration function is responsible for logical database design and data dictionary development. That's all about database and information management. I have posted some questions on online learning for you to answer. Try to submit those by today. That's all. Thank you.